Let's look at problem number 1. We have a series of absolute value problems. Let's just compute them very quickly. Notice when I write out absolute values by hand, I try to make the symbols a little bit thicker and maybe a little bit longer than you would normally write them out. Why do I do that? So I don't confuse them with the number 1. Absolute value of 8 is just 8. Absolute value of negative 7.2 is just going to be 7.2. The negatives go away. In this problem here, the absolute values serve as grouping symbols. So you do what's inside first. 10 minus 16 is negative 6. So I want the absolute value of negative 6, which would be what? Well, 6. This problem's a little more complicated. Again, absolute value serves as grouping symbols. So we do what's in the groups first. Absolute value of 1 minus 5, you do the 1 minus 5, which is going to be negative 4. And then for this group, you go negative 3 minus 6 is negative 9. Still an absolute value. Now we want to evaluate this part. Absolute value of negative 4 is just 4. The minus sign stays. That's not inside an absolute value. The absolute value of negative 9 is 9. And then 4 minus 9 is negative 5. And if you have some problems doing these additions and subtractions with negatives, or getting negative values, again, try using the handout that's provided to you with the number line. That might help getting these answers. Let's try the next problem. For question number 2, I want to rewrite these expressions in such a way as I can remove the absolute value symbols. But I want to leave the answer in the exact form. What does that really mean? Again, this is a little bit sneakier than other typical problems we've been doing. And you can probably guess, these are the types of problems that actually appear on tests. For the first one, the absolute value of the quantity 2 minus pi. Well, yes, you can actually subtract 2 minus pi and get some kind of decimal, but we want exact answers. So really, we want to leave this in a form that actually stays pi and it stays 2. But what happens if you actually subtract 2 minus pi? Would the answer be positive or would it be negative? It would be negative because pi is approximately 3.14. 2 minus 3 something is going to be negative. But we want to write this without absolute values and we want a positive answer. So the deal is just kind of switch them around. So you're going to write the larger one first. Pi minus 2. See, that will give you the same value as 2 minus pi, but it'll be a positive value instead of negative, because absolute values must be positive. So that is our answer. On a similar token, you have something that's a little bit even more intimidating looking, but it's really not that bad. Pi is approximately 3.14. The square root of 7, if you use your calculator or table of values or whatever, it's approximately 2.6. So 3 something minus 2 something is positive. Well, since it's positive, I really don't even need the absolute value. So I don't have to switch anything around. This is actually easier than we thought. Amazing. So the answer is just pi minus the square root of 7. That's it. For this last problem, again, I just mentioned that square root of 7 is approximately 2.6 minus 3. So 2 something minus 3, that's going to be negative. But we don't want negatives. So what was our little trick? To write this without absolute values, and we want a positive answer, switch them around. So we're going to get 3 minus the square root of 7. Again, if you feel kind of hesitant with these types of problems, go ahead and just punch this in the calculator, and then compare it with these answers. And these will be the exact same numbers as these, but these will all be positive. Now this one's already positive to begin with, but that's fine. But go ahead and try that, just to further convince yourself that this is okay. And again, this is a very important test question, so you probably want to go over this again. For question number 3, we want to find the opposites. Opposite of 5 is going to be negative 5. Opposite of negative 8 is going to be 8. Opposite of square root of 3, what's that going to be? Well, be careful. Make sure the negative is on the outside of the radical. A lot of people make the mistake of putting negative inside with 3 on the outside. Now I want the opposite of negative 6. Now you would say, no, it's the opposite of the opposite of negative 6. Ugh. Well, first off, what is this right here? Negative with negative is a positive. So this is really positive 6. What's the opposite of positive 6? Negative 6. And this last one, I want the opposite of x. That's like saying the negative of a negative, so it's positive. So this is going to be just x. For number 4, let's perform the following operations. Now for the first few over here, you can actually again use the special handout on the number lines to help you put these together if need be. 8 plus a negative 2 is going to be 6. Negative 8 plus 2 is negative 6. Negative 8 plus a negative 2, so negative, and it's still negative, so this is going to be negative 10. Now this one's a little bit different. We're using words now. Subtract negative 2 from negative 8. So I'm going to take the negative 2 away from the 8. So that's the thing that's being subtracted. So I start off with negative 8. Okay, and minus a negative 2. So for clarity, I'll put that within parentheses. And to subtract that, it's probably easy to change the signs and add. So it's going to be negative 8 plus the opposite of negative 2 is 2. I really don't need parentheses, I just put them there for emphasis. Negative 8 plus 2 is negative 6. And this one over here, negative 8 minus 2, again, if you just think about it right away, oh, it's just going to be negative 10. But officially, you change your subtraction into an addition. The opposite of 2 is negative 2. So this is this is exactly like this problem over here. So the answer is negative 10. Let's continue with some more. Now these problems here are some practice on using our rules of multiplications and divisions using positive and negative numbers. 8 times 2, positive times a positive is a positive, so I'm going to get 16. Negative 8 times 2, the signs are different, the answer is negative. So it's negative 16. Negative 8 times a negative 2, what's the rule? Negative times a negative is a positive, so positive 16. Deja vu. 8 divided by 2, they're both positive, so the answer is positive, and it's going to be 4. Negative 8 divided by 2, they're different signs, so the answer is going to be negative, and we're going to say negative 4. 4 cubed is 4 times 4 times 4. You can use your calculator or write out by hand. The answer is going to be 64. Now, the next one, the square of negative 5. Okay, so how would we write that out? Would this be okay? Here's negative 5, I want to square it. Is that okay? Well, no, because see, what's our order of precedence here? See, if you have a negative, that kind of implies kind of like multiplying by negative 1. You can think of it that way. And this is 5 squared, so the exponent has higher order precedence. So this is not the square of negative 5. This is the negative, or the opposite of 5 squared. So it's a little different. So to make this correct, I have to actually encompass the negative 5 within its own set of parentheses. And again, to really see that, instead of actually just scoring it out right away or using a calculator, let's actually just expand this out and put it in expanded form. You see, negative 5, the quantity squared, is negative 5 times a negative 5. Negative times a negative is a positive, so the answer is going to be 25. If you tried doing this officially on a calculator without the parentheses, you would get the wrong answer. It would have been negative 25, and that would not be correct. For this next problem, 157 divided by 157. Oh, that's pretty nasty. Maybe I should do the calculator. Well, no. Remember our rules. If it's the same number above and below on a fraction, what's the answer? 1. It's the easiest thing in the world. So you got to know the rules. And this last one, again, 301, pretty nasty looking. But again, it's just divided by 1, so it's just itself. There's a rule. That's a rule for that. And that completes question number 4. What is the distance between -5 and 7? Well, for this, let's just use the distance formula. What is the distance formula? D equals absolute value B minus A, or A minus B. I'm going to let, how about the -5 to be A? And I'm going to let the 7 be the B. So let's put that in here. So my distance, B, 7 minus A, which is -5. Again, for clarity, I will put that in parentheses. Let's simplify what's inside absolute values. So I'm going to get 7 plus 5. Put this together, I'm going to get absolute value of 12, and the absolute value of 12 is just 12. So that is your distance between -5 and 7. Question 6, I want to find the distance between x and y. Well, again, we use the distance formula. But now I'm going to let x be A and this be B. So my distance formula is going to be B minus A, y minus x. Of course, it doesn't really matter. I can say A minus B, B minus A. So if you want, you can also say the answer is x minus y. Doesn't make a difference. Which of the following is considered the best way to input 2 times 3 in a calculator? So of all these choices, they're all good, but the answer D is considered the best. Well, why? Well, it has the fewest number of keystrokes. 2 times 3 doesn't involve a lot of parentheses. Don't put any unnecessary parentheses, you don't have to. So keep it simple. Question 8 asks to write the expanded form of something that's in exponential form, or an exponent notation. So this is 6 to the 4th power. How do we expand that out? Well, it's pretty easy. You're just going to write down 6 times 6 times 6 times 6. 4 of them because to the 4th power. That's all you got to do. Question 9 asks to write the exponential notation for this expression. Well, the base is going to be 7 because that's the thing that's being repeated. And it's repeated how many times? 3. So that's going to be the exponent or the power. So it's going to be 7 to the 3rd power, or you can just say 7 cubed. Question 10 asks, what is the base of this expression right here? A lot of people would say, oh, it's -5, because that's on the bottom part, and the 2's on top, so that must be the exponent. Well, no. And again, we kind of talked about this earlier. Just the 5 is being raised to the 2nd power. If the negative were also being raised to the 2nd power, this thing would have been encompassed within a set of parentheses. So to answer this question, the base is just 5. Number 11 asks, what is the exponent of the expression 9 to the 5th power? Well, the answer to that question is just 5. Number 12 asks, which of these operations is performed first? So now we're talking about PEMDAS. So which of these operations would be performed? Well, there's no sets of parentheses. Are there any exponents? Yes. So to answer the question, you would just say the exponent. Or you can say square root of 4. For number 13, the question is asked, which of the following of these symbols is not typically used as grouping symbols? Well, I recognize all these things that we've worked with before except for those. So that's the answer. D, are not typically used. Question 14 asks, what is PEMDAS? Well, it's an acronym that is used to help us remember the order of operations of real numbers. P is for parentheses, and then you have exponents, multiplication, division, addition, and finally subtraction. Question 15 is a true or false question. Does subtraction have a higher order of precedence than division? How can we figure that out? Let's see. Oh, we'll just use this. Okay, the higher order precedence higher up, so subtraction is not higher than division, so the answer is false. No, it isn't. Question 16 is to simplify a series of mathematical expressions. Part A is this. So let's follow our order of operations to answer this. -3 times 2 plus 8. So order of precedence, multiplications before addition. So this is equal to -6 plus 8. Then what? Well, now we only have an addition right here. -6 plus 8 is 2. Part B is this expression right here. So the order of operations, I need to do what's in parentheses first. 2 plus 3 is 5. And times, I just leave that alone. And then that's just going to give us 25. Part C. So now we have a couple of grouping symbols, so we do everything what's inside each set of parentheses. 6 minus 2 is 4, and I'll just keep that in parentheses. 8 plus 1 is 9. Now what happens here? There's no arithmetic operation. Well, we talked about this before. If there's nothing between parentheses or parentheses and other items, it's implied multiplication. So this is actually 4 times 9. So the answer is 36. Part D. What should be done first? Well, we do what's in parentheses first. Now within the parentheses, what has the highest order precedence? We have an exponent. That's the first target. Everything else stays the same. 2 squared is 4. Now looking at this group, we only have addition and subtraction, so we go from left to right. 2 stays. 1 minus 3 is -2. And the 4 stays. -2 plus 4 is 2. And 2 times 2 is 4. For part E, with this expression here, we have a couple of sets of grouping symbols. So we go do the innermost set. Within here, what's done first? The exponent. So everything else stays the same. 10. 2 cubed. 2 times 2 times 2 is 8. Let's just keep doing this thing. And we do a lot of repetition, a lot of copying over, but that's fine, as long as you do it step by step. That is a very important thing to remember. A lot of people want to just zip right through these things, skip steps, make mistakes. So, 4 minus 8 is -4. And here, we still have this set of parentheses, so a plus and a minus. You can consider that as a subtraction, or you can just leave it the way it is and actually perform this operation. What is 2 plus -4? So let's do that. 2 plus a -4 is -2. Now let's put this together. Now here's a minus, a negative. So we can use our definition of subtraction and change that into a plus, and we get the opposite of -2, which is 2. So the answer is 12. For part F, we have something that's being raised to power to another power. So order of precedence, we do what's in parentheses first. So, what is 2 cubed? Well, we found out earlier that was 8. And it's still being squared, and then 8 squared is 8 times 8 is 64. Problem G. What should we do first? We have grouping symbols here, grouping symbols here. We do what's inside the innermost set of parentheses. So, 12 plus 2 minus 4. 2 minus 3 is -1. Notice how I still keep that in parentheses. Why? Because it's being raised to the second power. It's being squared. Next step, precedence, is the exponent. -1 squared is the same thing as saying -1 times -1 is a +1. So this is just 1. Grouping symbols. -4 plus 1 is -3. Now this is implied multiplication. That's an addition. So multiplication has higher order precedence than addition. So that's done first. 2 times -3 is -6. Ugh. How can we make this nicer looking? For clarity, put that in parentheses. Now what's 12 plus a -6? Well, that's just going to be 6. That's our final answer. Part H. We have grouping symbols here, grouping symbols here. Let's actually do both, going from left to right. So the outside negative stays. The absolute value of -3 is just 3. Again, I'll just put in parentheses just for clarity. Plus 8 plus 2 is 10 squared. Now I don't need parentheses anymore. I just did it for showing how I went from here to here. So I'm just going to rewrite this as -3. And then order precedence, the exponent's more powerful, it's higher precedence, so I'm going to go 10 squared is 100. -3 plus 100 is 97. Problem I. You recognize this thing? Yeah, this is the example we talked about earlier when I first introduced different types of grouping symbols. Well, now we get to do it. I can tell you're excited. So what should we do first? Well, we go to the innermost grouping symbols, and they're right here. So everything else stays the same. So 7 minus 6 plus, let's just copy this down. 2 plus 3 is 5. Now the innermost set of parentheses are right over here, our grouping symbols. 1 minus 5 is -4. And looking at this, we have this multiplication. That's implied multiplication with subtraction. That's first. So think of this as -4 times a -4 is positive 16. And there's a bar over everything here. What's next? Well, here's some grouping symbols. Five plus 16 is 21. Let's keep going. There's a bar over here. Don't want to forget that. That's important. And what's next? Well, look at this right here. If you have a grouping symbol and there's a positive on the outside, I really don't need the grouping symbol, or you can just ignore it. So you can think of this as the main grouping symbols right here, the bar. So you have 6 plus 21, and that's going to be done next. So that's going to be 27. And then 7 minus 27 is -20. For part J, there's a couple approaches for this. You can actually do everything in the numerator first, then everything in the denominator, and then divide the two. And that's fine. And I want to start that. Some professors actually tell you to do that. In this case, let's try to do a little bit on top, a little bit on the bottom, and so we can actually do the division between numerator and denominator. So looking at this, order precedence for the numerator is we've got to do the exponent first. So 3 cubed is 3 times 3 times 3, which is 27. And the rest just stays the same. In the denominator, the order of precedence is the exponents have the highest, so the rest just stays the same. 2 squared is 4. Now I only have addition and subtractions on top. They're the same, so I go left to right. 27 minus 1 is 26. On the denominator, I have multiplications and subtraction. Multiplication, higher order precedence, so I do the 4 times 3. So you get 12. 26 plus 6 is 32. 12 minus 4 is 8. 32 divided by 8 is 4. And that is her answer. Part K. Now I left the best problem for last. We have this thing. What's the first step? I know for a lot of students, the first step is to just panic. Or just skip it on the test, right? But no, we can do this, right? The key thing is to do it step by step and follow PEMDAS, okay? Let's get started. All right, the first thing we're going to do is, here we have a grouping symbols here, grouping symbols on top, grouping symbols on the bottom. Do the innermost set, which is right there on the top, and then here it is on the bottom. And everything else is just the same. So 3 minus 4 is negative 1. And here we did the grouping. So the first thing you have to do is the squaring. So that just becomes 4. Okay, let's keep going. Outside stays the same. Not anywhere near to figure out all this stuff yet. What's next? Well, order of precedence, I have to do the squaring first on top, and then the bottom I need to do what's inside the parentheses. So that stays. 4 squared is 16. And the bottom, 4 plus 5 is 9. Again, parentheses, maybe, maybe not. Let's just throw them in just for the sake of argument here. And now let's take a moment to erase the board and continue. So what would the next step be right over here? Well, for the top, I should do the multiplications, and the bottom, I can actually put those together. So that's next. And the rest, of course, stays the same. 2 times negative 1 is negative 2. And then 2 minus 9 is negative 7. I can now erase the bottom part. I'm done with it. And let's keep going. Let's do the addition on top. And the bottom just stays the same. And the outside stays the same too. Negative 2 plus 16 is 14. Now we do what's within this inner group. 14 divided by negative 7 is negative 2. And for this, here we have multiplication. So you can actually think of this as a negative 3 times a negative 2. So that's going to give us positive 6. Negative 11 plus 6 is negative 5. Whew, we're done. Well, we've reached the end of this lesson. Whew. I hope I was able to help, but if you have any questions, please don't hesitate to email me at this address right here below. And with that said, this is Luis Anthony Ast saying, keep studying. Bye-bye.